Hello friends, welcome to our website automationcommunity.com. In the last video, we have seen the ladder diagram programming of VFD control through PLC and HMI. So today we are going to design the HMI do its programming. So first of all, let us open the Upsoft HMI software from this icon over here. Click on the new file. For this project, we are going to select this 480 by 272 screen size and write over here your project name. Click on next button. Here in the for communication, you have to select your driver or simulator that you have created in ComGR and then click on finish button. So you can see this is our workspace. First of all, let us change our background color of screen. Click over here and let us select this color. You can select any color of your choice and click OK. So you can see our screen color is changed. Now visualize what are the objects you want to see on HMI screen. So I want to show forward button, reverse button and stop button. So you have to remember what are the address you used for each buttons. So now go to buttons. I will select momentary button for each case. So just select this momentary and draw a box like this. Double click over it to change its address. First of all, this will be our forward button which I have connected at X0 position and then click enter. Now we want to give its image. So for that we will go to pictures. From here select the library. I will use first library only. Scroll down. Let us say this image for unpressed condition and click OK. So here my image is visible properly. So I will select actual size. Select this as per your requirements. Now I want to show one text over here. So here I will write. First I will format my font. Make it bold, increase its size, let it be black only. And now I will write forward over here. You can see our text has become bigger, so let us reduce its size. Now it is okay. So I will just copy paste this and write over here also. Now for this condition also we want picture. So again go to same library and select this for pressed condition. So you can see when the button is not pressed it will appear like this, and if it is pressed it will appear like this. Here we have to make bold, so here also we will select bold. Now click OK. So you can see our button is created. Now just copy paste this to create the other buttons. Don't forget to change its address, button image and font. So double click over it. First of all we will change its address. So our reverse button is connected to X1 position. So first of all let us change its text to reverse. Here also I will write reverse. Now I will change the picture. So this time don't change the library, only click over here. So directly library will open, and this time we will select this image. This image for state 1 and for state 0 we will use this image and click OK and again click OK. So our reverse button is also created. Similarly here we will create stop button. So double click over it. Stop button is connected to X2 position. Now we will change its text. So here I will write stop this, and here also I will write stop. Now we will change its button image. So from here we will select red one. I have changed address, text and image and click OK. So our three buttons are created. Now we want two outputs. Actual outputs are Y0 and Y1, but we have connected that to S1 and S2 terminal. So click on indicator and we will select multi-state indicator to show our outputs. So just draw a box like this, double click over it. Here I will write its address. This is our output Y0. Click enter and we will give its picture also. So go to pictures and I will use vector button library. Here you can see vector button. From here let us select this for off condition. Here if image is not visible properly, click on stretch all. Similarly for on condition, we will go to same library. As you can see there are a lot of other images. You can select any as per your wish. Right now I am selecting this for on condition and then click OK. So you can see if it is on it will visible like this and if it is off it will appear like this. Now just copy paste this for our output Y1. So these are our two outputs. Now we want here a digital numeric input to enter the RPM given by user. So for that we have to select numeric entry or numeric from here numeric input. Now I will draw a box like this. Double click over it to modify this. First of all we will give its address. So this we want at D0 register. So I will write D0 and press enter. If you are feeling confusing like where we have to use X, Y and D, so for that watch our previous video and then come to here. So I have given the address. Now I want to modify this shape. So you can modify your shape from here. There are the different options. Right now I'm selecting this. You can change your border color also and background color. So right now I am selecting this and click OK. But before that, after that from here you can change the minimum and maximum settings. Say for example our maximum RPM is 1500. So from here we can select that is the maximum value can be 1500 only. Then there is the important setting of gain. So first of all I am writing a 10 over here and then click on this button. So you can see whatever the gain I have written is in the division. It is divided by our value. This is the input. If this is 100, input is 100, then output will be 10. If I write the 10 because it is dividing our input. So why we need to understand this? So as per the logic discussed in the first part of this topic, that is in the ladder diagram video, we have to get RPM from user and then we have to multiply 2.67 because we want one decimal value to give it to analog output module. But here whatever we will write in gain that will be divided by RPM. So what we will do, if I write like this 1 upon 2.67, so this will go to here and it will be multiplied like this. So this step is same like this. So if I write this value in the gain, okay, if I write 1 upon 2.67, this value in the gain. Okay, so what it will do, it will be same like this step only, multiplying by 2.67 only. So I am opening my calculator and here I am writing 1 divided by 2.67 and press equal to. So here I have get one value 0.3745. So what I am doing, I am going to my HMI and from this gain setting I am writing our user inputs, the required RPM is 1000. So what is the 1000 multiplied by 2.67? So it is kind of this, right? So here you can see in the HMI. So now click over here. Now you can see this is exactly 2.670. So if the user gives 1000 RPM and we multiply it by 2.67, it is 2670. And from HMI also you can see it is 2670. So both values are same. And close this and save OK. Another proof that if I write 1500 over here, then it should show 4000. So also this you can verify our first video when I have explained you the logic. If we want 1500 RPM, we have to move 4000 in data register. So from here also you can verify my calculation. So right now click OK. Similarly, this value, the value of D1 which I have told you, open this. So this is the value of D1, this I want to display. So again I will use data display. Draw a box equal to this size only, so both appear same. And its formatting also I will keep the same, like the border color and background color. So here I will write its address, data register D1. Press enter and again click OK. So this will show the converted RPM which will be moved to analog data module to give the required output. Now we want to see what will be the output by analog output module. This thing and the another thing, first let me copy paste this. So these two things have nothing to do with actual programming or actual application. These two things are for our visualization. Then when the user enters the RPM, what is the process occurring with this? First we are converting this into this value, and this value is converted by analog output module in this output voltage. So first of all, let me double click over it. First of all, we want to read D1 only, so I won't change its address. Now this is the output voltage, so we want it in 2-digit and in fractional also 2 digits. Okay, that means after this point we need 2 digits. Now there is an important setting related to gain. I will explain you. Friends, input, that is when we are getting input from user in RPM, at that time we have seen that gain is divided by input given by us, but at that time we wanted to multiply RPM by 2.67. So we wanted to multiply at that time, but gain is doing division function. So we have taken inverse of 2.67. So it is like, so this is our gain, we have taken inverse. So what it is going upward and multiply like, become expression like this only, right? Now this time we want the numeric output, that is in the PLC there is data register D1 we want to display this D1, okay, but at this time gain is multiplied, but what we want to do, we want to do division, because say for example if the data register is 4000, we want to make it into volts, and it should be 10 volts, equal to 10 volts, so we have to divide it by 400, right? So here we want to divide, but gain is multiplied, so again we have to take inverse. How? Let us say 4000 is multiplied 1 upon 400. If we multiply this by 1 upon 400, then we will get 10 volt. So let me open my calculator. So here we can see 1 divided by 400, it is 0.0025, okay. And here we will write 0.0025. We want output like this, 2 digits after the decimal point. So here I will write 2 integer digits and 2 fractional digits and click OK. So you can see over here. Now let us simulate this. So our screen is loaded. Now let us write 1500 RPM. So you can see D0 is moved. Now click on this button to move this data, so we can see these two things. So let us click on and then off right now, because right now I haven't created set RPM button over here. So you can see D1 is showing 4500. This is the value we will give to this instruction, so that analog output module produced 10 volt. But right now here we can see it is not 10 volt, it is 0.010. So we have to reduce our multiplier. So close this. So this time we will reduce these zeros. This thing we can know by trial and error method only until we get our desired value. So now again click on the simulation. So this time you can see for 1500 RPM we want 10 volts in analog output module, and that can be possible when the data register is 4000, okay. So now our calculation for this output voltage is correct for gain settings of this output. Now let us close this. If you are feeling any doubt, just see my simulation and doubts will be clear to you. Now here we want one button to set the RPM. So again I will select momentary button, throw a box of size equal to this, and then double click it to change. First of all, give its address M0, because in programming we have M0 for this move operation. Now I will write its text. So make it bold, increase its size, and here I will write set RPM. Same I will write over here. Here also we have to make bold, and we will change its background color for both on and off condition. For on condition, let us say it is in color, and click OK. So if the button is pressed, it will appear like this, and then it will come back to this position. Now we have to write text for each element. So select a text box from here, a box like this, double click it, and let us change its background color, write it text, click OK. Let us align this from here. Similarly, we will give text to other elements. So this is our set RPM. So first of all, I will write over here set RPM, make it bold, align it center, and change its background color. Okay. So similarly, just copy paste this for remaining items. So this is our value of D1 register. So here I will just write press enter, and this is our output voltage produced from analog output module. So here I will just write output voltage. Again copy paste this. This is our output connected to S1 terminal, and this is our output connected to S2 terminal. So here I will change it to here S2. So here our HMI designing and its programming is completed. Let us do its simulation. So first of all, click on here simulation. First of all, open your ladder programming and open the COM-GR. So I am opening the COM-GR. Select your simulator and click on start button. Our simulator is started. Now compile this and download to PLC. It is transferring to our simulator. Close this and enable this bit and click on run button. So here you can see our simulator is in run state. Now open your DOPSoft HMI and click on simulation button. So first of all, we will understand the set RPM operation. So here let us write 1500 and press enter. Because we have done here gain settings, so it is doing mathematical operation in the point are round off, so it is giving the near about value of 1499. So here you can see D0 is moved, but D1 is still 0, you can see over here. So we have to click on this button, so this set RPM operation will be done. This is the momentary button, so it will become on and off. So let us click over here. You can see it became on and off and move instruction executed and D1. So this is the value that we will write in this code. Okay, you can see over here. If we move this value in data register, then our analog output module will give this voltage, and if we give this voltage to VFD, then VFD will run at our desired speed. So we will verify this. Before that, let us understand this forward and reverse operation also. When I will press this forward button, this X0 bit will be high, and again this is also momentary switch, so it will off automatically, but it will let our output Y0, which is connected to S1 terminal of VFD. So let me click over here. So you can see our output is latched. So my output Y0 is on, which is connected to S1 terminal of VFD. Now I will use VFD software to verify that our program is correct or not. So first of all, we will open our VFD software from here. So I am opening it. Right now we will click on new project. Any name to your project and click OK. And again just click select drive. So our simulator has loaded. First of all, we will click on view and edit drive parameters. For our current project, We no need to change any parameter, just we have to change the frequency. So I am going to E parameter, motor parameters. In that E104 I will change this to 50 Hertz. So double click over it and just write 50.0 and save. It will ask for accept, so just click on accept. And red means this is changed by us. Here you can see default value. If you want to set default, again in E106 base frequency we will do 50.0 Hertz. So again I will write 50.0, click over save value. So this is it for this project. Remaining settings will be as it is. Now I will click on program simulator, close this box. So first of all let us on the main power. Now bring us HMI screen. So this is our HMI screen. So what our PLC output is, first of all S1 on, S1 should be on. So let us make S1 on. Y0 output is high, which is making S1 on, but you can't see any RPM because the analog voltage input is 0. Here you can see if we give 10 voltages, it will run to 1500 RPM. So let us give this 10 voltage, you can see over here, and here it is accelerating. After some time it will achieve its full speed. Here you can see the direction, it is in forward direction. From here also you can see if it will be reverse, this light will glow. So it is picking up the RPM. Now you can see it is reached to 1500 RPM. This case I have taken so that you can understand the concept. Now we will see the different cases. First of all let us see, we want 500 RPM, okay, user wants 500 RPM, so click over enter, but RPM is not set yet. We have to click on this button to set the RPM. So as soon as I am clicking this, it will convert our RPM into 1335. This value will be moved to register of analog output value. So analog output module will give us 3.33 voltage in output. So let us give 3.33 voltage to VFD. So it is near about 3.33. Okay. Now we will observe RPM. You can see 497, which is near about to 500 set by us. You can see. So our project is giving near about value to our desired RPM. Now we will consider the another case, reverse condition. If we want to move the motor in reverse direction, first we have to stop our motor. So we will click on HMI stop button. You can see S1 is off. So here also we will do S1 off. So now it is deaccelerating. You can see it has become to stop condition. Now I will click on reverse button. So as I am clicking reverse button, S2 terminal is on, white one is on, which is connected to S2. So let us make S2 on, and now you can see here it is reverse direction. Here also you can see reverse direction. Okay, so this is right now moving in reverse direction. Let us consider a different speed case. Say for example, we want 800 RPM. User wants 800 RPM. But still the speed is not changed because we have to click on set RPM button. As soon as I click on this, RPM is converted, RPM is getting multiplied by 2.67, so that value is 2136. If we move this value in register of analog output module, it will produce 5.34 voltage. So from the simulator we have to give 5.34 voltage to VFD. You can see this is near about 5.34, okay, 5.34 voltage. Here you can see it is near about. So observe here 807 RPM. Right now it is in reverse direction because S2 is on, okay. Here you can see reverse. This is near about our set RPM, which is the 800. Here it is moving 807. So in this way you can see our project is working correctly. You can test different scenarios as per your wish. Okay. If you want to explore this VFD simulator, I have already made separate video on that. Right now, for this project, we only need to change the frequency. Rest of the parameters will be same, and you can test our HMI and PLC programming like I have tested it right now. So thank you guys for watching this video. If you want to learn more examples like this, show your interest by liking and subscribing our YouTube channel. Meet you in the next video with another interesting example.